Hey everyone, welcome back to this channel and I hope you are doing very well. Today we are going to see the gray code problem, and the problem statement is a gray code is a list of 2 to the power n bit string of length n where any two successive string differ in exactly 1 bit, that is their humming distance is 1, and our task is to create a gray code for given length n, and we have given only one integer, that would be n, and we have to print 2 to the power n line of describing the gray code, and we can print any valid solution, and the constraint is n is less than equal to 16. So let's say if I am taking n equal to 2, then I have to print all the possible string of 2 to the power n bit string in such a manner that it would be a gray code. So what is a gray code? The gray code is defined as two successive string differ in exactly 1 bit, that is the humming distance is 1. Let's say I am printing all the string for n equal to 2, that would be 0 0 0 1 1 0 and 1 1. So what is the difference of all set bit in these two successive string? That would be 1, and this is my humming distance. Okay, and for this this is the total number of set bit in this string is 1, also in this string is also 1, then 1 minus 1, that would be 0, and for in these two string that would be 1. So here the humming distance is 0, then this is not a valid pattern. So how can we make a valid pattern? So if I write this 0 1 1 1 then 1 0, so for these two string that would the humming distance is 1, for this also the humming distance is 1, and for this also the humming distance is 1. So this is a valid pattern, and I can print this as a gray code. Now the question is, how can we get this pattern? For creating this pattern, first of all I have to create the all possible string for n. So how can we get the all possible string? I can get all these possible string by recursive call. How? Now I am breaking this problem into the simple one. For n equal to 1, what would be my all possible string? That would be 0 and 1. Okay, and for n equal to 2, how can we get the possible string? I can easily get the possible string by utilizing the n minus 1 all string. How? First of all, if I am prepend 0 in these two string, that would be 0 0 and 0 1, and after that if I am prepending 1 in these two string, that would be 1 0 1 1, then these are all my possible string for n equal to 2, and after that I have to just make a pattern from this for making this a gray code. Okay, so is this a gray code? That would the humming distance between these two is 1, and humming distance between these two is 0, and humming distance between these two is 1. So this is not a gray code. So how can we make this as a gray code? So if I look closely, where I can find this all string? I can find this all string from the n minus 1 string, that would be 0 and 1. Okay, after that what I am doing, I am just prepending 0 then 1. Okay, so if I have n equal to 2 and I am getting, first of all I am getting the all string from n minus 1, that would be n equal to 1, that would be n minus 1. Okay, so what I have to do, I am just taking 0 1 and 0 1, and first of all I am prepending 0, after that I am prepending 1, and just store this string in a vector, and we just check the humming distance, that would be 1, the humming distance between these two, that would be 0, and humming distance between these two is 1. So this is not a valid case. So if I reverse this from top to bottom, then what we have 0 0 0 1 1 1 and 1 0, then humming distance is 1, humming distance is 1, and humming distance is 1. So this is a valid case. So what I am doing over here is for n equal to 1, what is the total string over here? That would be 2. For n equal to 2, what would be total string? That is 4. if I'm generalizing this term, the total number of string for n is equal to 2 into y2. In first case I am prepending 0, in second case I am prepending 1. So 2 into total number of n minus 1 string. Okay. So after generalizing this, I have to calculate the all string for n, where I can get this from n minus 1. So here n is equal to 2, then I just have to first of all I just have to store all the string of n minus 1 for n minus 2. First of all I have to just store the all n minus 1 string, that would be 0 1, and I store, let's say I am store this all string into vector of string. After that what I am doing, I am just reversing it. So I am just taking one more vector of a string and taking the all input of vector, and after that I reverse it. Okay. Now what I am doing after that, I just have to prepend 0 and 1. So after prepending 0, that the updated vector of a string would be 0 0 and 0 1, and after that my as we can know, the total number of strings of n is equal to 2 times. After that we are just pushing the one preempted string into the vector of a string, that would be 1 1 and 1 0, and this is my valid grade code. Okay. Now coming to the time complexity. What we are doing? We are doing the recursive call and we are printing this string. So what is the total number of string? That is the 2 to the power n, and for recursive call the only one active state, which is n. What I am doing over here, I am just calling a recursive call and decrement n by 1 till n is not become to the 1, and 1 is my base case. When I got 1, I just return 0 and 1. Okay. So the overall time complexity would be 2 to the power n, and for the space complexity, at each n, at each recursive call, I just create a vector of a string and store n minus 1th string. So at each n, I just create a vector of a string and store n minus 1th string. That would be and what is the length of the all string? That would be 2 to the power n minus 1. This is similar. This is equivalent to 2 to the power n. So the overall the overall space complexity would be n into 2 to the power n. Okay. Now coming to the code part. First of all, I have to take input of n. Then after that, I am creating a vector of a string. That would be my answer. That would from here I call my recursive function, and for each answer I just print my all 2 to the power n possible string. Okay. After that, I just create a vector of string function. The function name is fun, and initializing my parameters. Okay. And first of all, I am just writing my base case, that is if n is equal 1, I just have to return 0 and 1. Okay. And if my n is not equal to n, then first of all I want my n minus 1th all string. Okay. So after that, I am just initializing my another vector of a string, that would be, let's say it is vec, and just take all the n minus 1th vector of string. Okay. And after that, I just initialize one more string, vector of a string, that would be temp, which is also equal to vec, and just reverse. Reverse temp, begin temp dot end. Okay. Now I just take the all the string of n minus 1 and store in a vector of a string, and also take also store the reverse of n minus 1th string in a temp variable. So what I have to do further, I just have to further uh, adding 0 in the vector of vec of string and add 1 in the temp of a string and just return my vector. Okay, so for first of all I just take the size size equal to vec dot size. Okay, after that I initialize my iterator from 0 to I less than equal to size from I plus plus. Okay, so first of all I am prepending the 0 into vec of a string. So I just make a 0 adding 0 in vector of I and string adding 1 in vector of in temp of I. Okay, and after that what I have to do, I just update my vec I equal to zpre. That means I am just updating over here that let's say if for n equal to 1, this is my 0 and 1 vector, and for temp this would be 1 and 0. So what I am doing over here, I am just prepending 0 in 0, let's say this is 1, and just add 1 in temp and push this element into vector, that would be 1 1 over here. Okay, zpre and vec dot push back o pre. Okay, and after that I return what I return vec. Okay, so now for this is for 0, and if at this iteration I just adding 0 and update my vector and adding 1 and push into this vector. So my updated vector would be this, and the humming distance is 1 over here, and the humming distance is also 1 over here, and our humming distance is also 1 over here. Now, and this is a valid pattern. Now let's run my code and check if it is working or not. Now it is working fine, that is all the humming distance is 1, and now this is a gray code. Okay, so let's try to submit this code and check if it is accepted or not. Okay, and it is accepted. Okay, so if you like this content and if you want more, please like this video and subscribe to this channel. And if you have any query, if you have any doubt, then please reach out into the comment section. So thank you, let's code, bye bye.